Well, welcome back to the 7 steps of the scientific method and your science fair project. We left off with step 3, formulate a hypothesis. We talked about an educated guess and what an educated guess is. What I'm going to do right now is bring up an example of what a hypothesis might look like. So the example that I have here is, if soil temperatures rise, then plant growth will increase. So let's think about that. Because that's an educated guess, because we have some knowledge of that. Living in Minnesota, we have 4 seasons. We have spring, winter, fall, and summer. If we think of those, and you think of the soil temperature during those seasons, and think of what's growing during those, if you think of winter, the soil temperature will be very low. Obviously, and when you look out in the winter, the grass is brown if you can see it, if it's not covered with snow, but there's no leaves on the trees and things like that. So as the soil temperature rises in the spring, and it gets warmer, things start to grow. So plant growth then does increase as the soil temperature rises. And then as you go through summer, you see lots and lots of green flowers, things like that all growing. So that's a pretty good example of how we can make a educated guess by things that we know. And it's educated because we have learned those, we have seen them, we have done that background research. So that's your hypothesis. Step 4 is our experiment. This is usually the fun part. This is when you get to, with your parents or by yourself, get to develop and follow a procedure that you're going to carry out. And a lot of kids really enjoy this part of the scientific method because it's the hands-on part of the method. And as you see here, here's some of the things you need to have. You need to obviously develop and follow a procedure, which means you need to come up with a materials list, which is a list of everything that you're going to use in your experiment. Now, let me reinforce that by saying it is everything. Every single item that you're going to use and the amount of stuff that you're going to use must be listed in this materials list. Because if I want to redo this experiment, I need to know exactly what to do and what to have so I can reproduce this experiment. So we're going to come up with a procedure as well. Your procedure is your step-by-step list of how do I do it. Think of a recipe. If you're going to bake a cake, okay, well, there's a certain recipe that you must follow in order to make that cake bake and be successful with it. If you don't follow that procedure, that list of things to do in this order, it might not work out as well. So we need to come up with a procedure. We also need to come up with a materials list of everything we need. So that's part of step 4. So the last thing for your experiment that we need to have before we even start the experiment is we need to figure out how we're going to measure it. Okay, quantifiable is just another word that means measurable, same type of thing, but the outcome must be measurable. And we've talked about, or will be talking about in classroom, all those different ways of measuring different things, whether it's length, whether it's time, whether it's weight, mass, things like that. Your outcome, the answer, when you're done, the experiment must be measurable of some kind, with some way. Okay? So moving on to step 5, then after we're going to do our experiment in there, we've got all those things, we've got our procedure, we've got our materials list, we've figured out how we're going to measure it, we do our experiment. And that's the fun part, the hands-on. We'll get more into that in class, talk about different types of experiments, and we will actually do a couple on a later video as well. But then we're going to get into how we're going to collect and analyze our results, which means we're going to take that information, how did we measure all the things that we measured, however we measured them, and we're going to analyze them and see what happened. Here's where we might make a chart. We might make a graph to show the different results of each of the things that we were testing. At this time also, we may need to modify the procedure if necessary, which that means is, hey, you know what, we did our experiment and the results really didn't change, or there wasn't a big enough discrepancy or difference in our experiments. We might need to change that a little bit and go back and redo the experiment again in a different way because we didn't get any results, or at least they weren't different enough to make it that this one does stand out more than the rest of them. So we may need to modify that if at all possible. Then we are going to actually retest if we did get good results, and yes, this one was better or however it worked out. Then we need to confirm the results by doing that test again. What we like to say, or what I kind of require, is that you do it at least 3 times. So you're going to do that same experiment 3 times to see, do I get the results the same every single time? And if I do get the results the same every single time, then I can pretty much say that that is going to be a good test. So we're going to stop right here because I think we've got enough to talk about in class at step 5. There will be another video coming shortly with step 6 and step 7. So be looking for those. But come up with, hopefully you'll come up with a way to do your experiment and maybe think of some different materials, a procedure, how you're going to do it, come up with those and how you're going to measure your experiment. That will be kind of your homework assignment to come in the next day with those types of things. Okay?